Greetings, everyone. Welcome to today's presentation. Generative AI has become a crucial tool for enhancing workplace efficiency. Many enterprises are exploring how AI can automate daily tasks, accelerate decision-making processes, and boost employee productivity. However, internal corporate data often contains highly confidential information, such as financial reports, customer data, and patented technical documents. If leaked, these could significantly impact a company's competitive advantage. As a result, many businesses aim to develop their own AI models, allowing employees to leverage AI for improved efficiency while ensuring that sensitive data remains securely within the organization. However, training an AI model is expensive and time-consuming, requiring extensive computational resources, GPU servers, data processing, and prolonged model training. For most companies, this presents a significant challenge. High costs, development and training can cost millions of dollars. Specialized resources requires AI scientists, engineers, and high-performance GPU servers. Infrastructure demand. On-premises LLM training needs large GPU clusters and high-speed networking. Cloud AI services, convenient but expensive for long-term use, for example, OpenAI API. Data security risks. Confidential company data may be exposed. The rapid advancement of AI is transforming how businesses operate, prompting many enterprises to ask, how can we build an internal AI assistant that helps employees quickly access information, solve problems, and safeguard confidential data from external exposure? Traditional AI services such as OpenAI API and Google Bard offer powerful capabilities, but they come with high long-term costs and require data to be transmitted to external servers, posing a significant risk for enterprises that prioritize data security. Additionally, off-the-shelf AI models may not fully understand a company's internal business logic, making them less effective in providing truly tailored solutions. As a result, businesses need an AI assistant that is internally deployed, highly controllable, and capable of continuously learning from internal knowledge. Our solution is the Expert Mode plus Private On-Premises LLM, Large Language Model. This approach allows enterprises to deploy an internal LLM combined with expert knowledge bases, enabling AI to learn and reason based on domain-specific company data. By utilizing an on-premises LLM, organizations can benefit from a highly efficient AI assistant while ensuring that all sensitive data remains within the internal network, eliminating external access risks and strengthening information security and compliance. Expert mode. No need to train LLM from scratch. Use open source models, for example, LLama 37B. Pre-trained LLM and internal knowledge base ensures highly relevant responses tailored to enterprise needs. Fully intranet deployment, no reliance on external APIs, ensuring 100% data privacy. Cost-effective, runs on existing servers without additional hardware investment. Ideal for internal knowledge retrieval. Supports FAQ, technical support, and document searches. In this architecture, users interact with the LLM through the chat API. For example, a user might ask, "What are the specifications of our latest product?" Once the query is sent, the chat API receives the question and passes it to the LLM. If the data is already in the index, the LLM will return the answer directly. If the data is not in the index, AI will retrieve it from the knowledge base and create a new index for the query, enabling faster responses for similar questions in the future. In this architecture, users interact with the LLM through the chat API. For example, a user might ask, "What are the specifications of our latest product?" Once the query is sent, the chat API receives the question and passes it to the LLM. If the data is already in the index, the LLM will return the answer directly. If the data is not in the index, AI will retrieve it from the knowledge base and create a new index for the query, enabling faster responses for similar questions in the future. Administrators must ensure smooth operation of index data. The LLM uses Retrieval Augmented Generation (RAG) technology to optimize query results. Administrators also need to adjust index storage strategies based on query frequency, ensuring maximum query efficiency and enhancing overall performance. Administrators must ensure smooth operation of index data. The LLM uses Retrieval Augmented Generation (RAG) technology to optimize query results. Administrators also need to adjust index storage strategies based on query frequency, ensuring maximum query efficiency and enhancing overall performance. 1. Why is storage architecture crucial? Traditional AI services store data in the cloud, which leads to the following issues. Data security risks. Confidential data is transmitted over external networks, which can lead to leaks. Query delays. Cloud storage increases latency, affecting response speed. High operational costs, long-term cloud storage, and API request costs are expensive. Solution: fully deploy LLM within the internal network, supported by a high-performance storage architecture. 2. Internal storage architecture design. An enterprise internal AI assistant needs to store large amounts of data, including raw data such as technical documents, knowledge bases, etc., and index data, structured indexes created by AI after processing. We divide the storage architecture into two parts. Raw data storage. Suitable for large-scale data storage, recommended options include HDD, low cost but slower access. Hybrid storage, HDD plus SSD. Improves access speed, suitable for data analysis. Index storage. Stores index data processed by AI. Recommended options include NVMe SSD, low latency, high performance. All-flash SSD. Improves query speed and reduces latency. The layered architecture ensures data security. Data is only stored within the internal network. Faster query speed reduces processing time. Cost optimization. Performance and costs are optimized based on demand. 3. How to ensure AI data access efficiency. We use the XN 2216 storage server and design an efficient data access mechanism. Users ask questions via the web chat API, and AI quickly retrieves data from the index NVMe SSD. If the data is indexed, AI responds immediately. If not, it retrieves and updates the index from raw data HDD pool. This architecture ensures faster query speeds and allows for continuous optimization of storage resources based on demand. Let's discuss AI model size, hardware requirements, performance, TPS and latency, and corresponding storage configurations. When choosing an AI model, the question often arises, should we choose a smaller LLM for faster response times? While smaller models, 100 m tilde 1.3b parameters, can run on low-spec hardware with high TPS and low latency, the hidden risk is a significant drop in accuracy, inference capability. Here's a comparison. 0.1b, 100 m LLM, suitable for simple AI tasks like IoT or mobile AI assistants. TPS 500 plus, response time less 1 second, but low accuracy, often prone to errors. Stored on HDD, low cost, high capacity, slower access. 1.3b LLM, suitable for basic chatbot NLP tasks with limited inference capability. TPS 200, 500, response time 1, 3 seconds for basic AI apps. Stored on HDD for small AI record needs. For more complex enterprise tasks, tech support, internal knowledge queries, professional analysis, these models fall short, and larger models are needed without sacrificing TPS and latency. Here's how larger LLMs can achieve similar performance with high-performance hardware. 7B, 13B LLM Enterprise FAQ Customer Support AI offers higher accuracy for medium knowledge queries. TPS 40, 60, response time 3, 8 seconds, can lower latency with high-spec GPUs RTX 4080/A100. Requires hybrid HDD plus SSD storage for better query efficiency. 30B, 70B LLM Expert AI Enterprise Decision Support performs well with technical queries and high-precision knowledge retrieval. TPS 80, 150, response time 2, 5 seconds with A100/H100 servers. Requires all-flash SSD for low latency and high performance. 175B LLM, GPT-4 level enterprise AI. Handles extremely complex tasks like strategy analysis and predictive modeling. TPS higher than 500, response time less than 1 second with multiple H100/TPU servers. Requires NVMe SSD for ultra-fast access and optimal inference performance. First, visit the official Llama website, download and install it on a server with GPU acceleration capabilities. We will use the Windows platform as an example. In the Windows CMD, enter the above command to run the Llama service. Here we use the Llama 3, 18B model as an example. Depending on the hardware architecture, you can also choose other language models. A Llama is an AI model running based on Docker. Next, we will need to install Docker first. First, clone the LobeChat database to your local machine, then enter the local directory. Edit the .env file to configure external settings such as database and storage. Then, use Docker Compose to run the service. Enter localhost 3210 in your browser to access the LobeChat page. At this point, you will also need to mount the locally downloaded LLM model. Click on the session settings in the top right corner of the screen. Click on AI Service Provider to a Llama. Enter the IP address and port of a Llama into the Interface Proxy Address field, then click Fetch Models on the right side of the model list. LobeChat will start searching for the local LLM model installed via a Llama. Finally, select the desired model, and you can begin chatting with the local LLM model through LobeChat. After training, the model can answer content from the knowledge base. Below is a guide on how to create and train a knowledge base. Click in sequence to create the knowledge base. Click to enter the previously created knowledge base and upload the file. Currently, the supported file formats are HTML, TXT, and other text-based file types. Next, click on Chunking on the screen to start training and generating vectors. When you see the purple numbers, it means the vectors have been trained successfully. Each file typically takes less than a minute to complete the training. At this point, return to the conversation page, check the knowledge base you just trained, and LobeChat will be able to answer based on the content of your internal knowledge base. It will also indicate the source of the information used for the answer. With the rapid development of AI technology, businesses must consider not only the scale and inference capabilities of AI models, but also the storage architecture configuration when selecting the right AI model. Whether it's the high-performance response of smaller models or the efficient storage support required by larger models, finding the right balance between hardware and storage needs is essential. Only by combining the appropriate AI model with an efficient storage solution can businesses ensure accurate and fast data processing on a high-performance foundation, thus improving overall operational efficiency. In this ever-changing technological landscape, choosing the right AI solution will be a key factor in a company's competitive advantage.